Hi everybody, welcome back to the channel and welcome to a new episode of Project LS400. It has been a while since I last worked on the LS, and unfortunately I will not be working on my own LS400 in this episode. I will be working on a friend's car over here at my bench. I'll explain that after the intro. Before I forget it, I include chapters in the video so you can skip ahead to the part you'd like to see. Anyway, roll intro. So what am I going to do in this episode? Well, as I said, I'll be working in my shed, which is 2 by 3 meters, on this tiny little bench here. So you may have guessed that I'll be working on a specific component, and that component is this ECU over here. I've done several videos on ECU repairs, but I wanted to make a short, new, fresh video on the subject and tell you and show you how I do this. Now, this ECU factually is not from a Lexus LS400, it's from a Toyota Celsior, which is the JDM version of the LS400, right-hand drive for the Japanese market only. Little backstory, this ECU comes from a friend's car. He imported it from Japan. It is a Toyota Celsior, it literally is a Toyota Celsior, so not a right-hand drive LS400. And he bought this extra ECU with the car, and it says on top here, I'll show you, UCF11, which is the model designation, the internal model code for the Toyota Celsior. He bought this as an extra because he expected that the ECU that was original to the car would be bad. When he installed this ECU, the car ran fine for a short period, but after that car went in limp mode and it became undrivable. He currently drives with the original ECU in the car, and the car is running fairly fine, but he says he wants this ECU repaired. So I will see what I can do. So I'll set the camera up and we'll open up this ECU and, well, let's see what we can find. Okay, let's open up the casing, make a little bit of room. I've cleaned my worktop. Let us see what we can find inside here. So I'm not sure if anyone has ever been in here before, but I think we'll find out. There are some scratches on the outside. So you can have a little soot on the inside of the housing. And look at the top of my finger, there's a little bit of soot coming from the electronics. And I can see straight away that this is a completely different ECU than in my own LS400. One telltale sign is this stud over here. So let's see. Let's first remove the cover on the other side. Well, it looks very nice and clean, and that has not been worked before on this circuit board. Also, the pinout over here is different. I learned that every time that Lexus made an update to any part, especially the ECU, the plugs in the pinout is not compatible, so you cannot use this in another car. This ECU cannot be used in my LS400 unless I make changes to the wires and connections, and that's something no one is ever going to do. Okay, there are some components that are mounted to the side here. This acts as a heat sink, so we should not forget to remove that. Let's start with those. You can see there is a larger washer on the screw that's in the center. I think there is a standoff in between to prevent the circuit boards from bending. which is highly unlikely to happen, but better safe than sorry, I guess. So now this part is loose. Let me undo the circuit board on the other side, and I leave this one in because I think that the standoff is secured on this one, so we don't lose that part. Okay, let's see if we can get this out. I can see from the soldering points over here that those ribbon cables are on this side. Oops. Can I remove it from the housing? I'll try to. There we have it. So now it's removed from the housing, and now I can start my inspection, which I'm going to do off camera, and then I'll show you what I'm looking for. Had a bit of trouble with the camera focus, but in those two capacitors, they are tipped over, but I can also see that they are stuck together because the entire circuit board has been submerged in some kind of varnish, a lacquer, to protect it from corrosion, so it's all over it, and those two are stuck together. Good news is that there is no leaking capacitor. I haven't been able to find anyone. So, and if I had to judge it from looking at it, let me zoom out again. So at first glance there is nothing wrong with this. You just look at this, everything seems nice. There are no heat spots where things have been excessively hot. So this looks pretty good to me. I find it very interesting to see in this circuit board. So it's the same as in the other UCF10s. It's folding, but I believe the other ones were folding on one side and not on the long side and not on the short side of the circuit boards. But you cannot test or judge if this is a good ECU just by looking at parts. I know from my friend there is something wrong with this ECU because when he installs this and the plugs and the connectors are compatible, so it should work with his car. It has the exact same part number, but with this ECU it just doesn't want to work. It's safe to assume there is something wrong with this. Now the only thing that I can do is replace the capacitors, because oftentimes they are the ones at fault. They're always the ones that go bad after time, and even though they don't leak, I can show you a picture, or I will insert a picture of a leaking capacitor, what to look for. It's pretty obvious. But I didn't find any leaking capacitors, but I will replace them anyway. So the next thing that I'm going to do is write down the positions and the values, because, and I will take the camera out and hope I can show you this in a macro function. So here we have a top-down view from the circuit board. Those were the two suspect capacitors, which look to be good, but if you look up close, every single component is marked, and I must say the quality of the circuit board is just perfect. This is so beautifully made. But anyway, I'm gonna use those tiny little markings on the circuit board to write down the position of the capacitor and its value. And after that I'm going to use my desoldering station to desolder all the capacitors. Well, took some time because your eagle-eyed host isn't so eagle-eyed anymore. With the use of a magnifying glass I've been able to read the values of all capacitors, and I will include them in the description. So if you have one of those ECUs with the exact same part number, which I'll also include in the description, you want to do this job yourself, then you know beforehand which capacitors you need to order. So let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 capacitors in total. So now I'm going to see which ones I have in storage, and if need be I'm going to order the ones that I don't have. It seems like I have all the necessary capacitors in the right value. There's only one that's a little bit of a question mark, which is position C108 10 volt 220 microfarad, and I only have 16 volts instead of 10 volts, the same microfarad. So I'm gonna check. I don't know this from the top of my head if I can use that one, so I'm gonna research that a little bit more. Well, I checked the good book on capacitors, and it says it's safe to use a capacitor with a higher voltage, but the capacitance, the microfarad reading, has to be exact. So now I know that I have all the capacitors. I will now start desoldering all the old capacitors. Now to desolder the components, I use this desoldering station which I bought last year. I haven't used it much, but I've done this a couple of times before, and always without a desoldering station, using a desoldering pump. One of those things that you press in, and then you heat up your soldering joint, push it, and it sucks the solder in. But this is such a pain to use on those small components, so I invested in a soldering station, and if you do this kind of work on a regular basis, this is highly recommended. So let's switch it on and see if it still works. I have the temperature set to 250 degrees, which is 482 Fahrenheit, and I think that'll work just fine. So I'm gonna start off and make a time lapse of this. Now to find the exact right soldering joints, I usually use a flashlight from the back, and now I can see the outline of the capacitors that I need to replace. So it's pretty hard to find the right soldering joints from the back, but this is my preferred method. Let's see. Start with the upper one. So there they are. Those are all the old capacitors that I took out, and just for fun and giggles I'm going to measure them and to see how much they deviate from the value that's on there, and then it's easier to spot which one is broken. A couple of weeks ago I tested this amperage meter, or an amperage clamp, not sure how it's called in English. And to my surprise, I saw it has a setting for capacitors, so I can test capacitors, and I've tested it already on a couple of new ones, and it works perfectly fine. Only thing is the test has to run for a couple of seconds, so I'm just curious to see how these old capacitors are actually doing. Let me see. This one's just for fun and giggles. This is nothing serious. 63 volts and 47 microfarad, and it says 54 microfarad. It's a bit higher, but not sure if this is bad. Well folks, the results are in. I'm really happy now with this little device over here. It proves to be very useful. Not sure how precise it is. I mean, it only cost me 15 euros, but the amp reading is very spot on. I tested that, and also I like to think that the readings of the capacitor test are really spot on. So here are the results. Starting with the upper 4. You can see the first one should have 47 microfarad, and it measured out at 54, and I marked it with that stripe at the back. And the first 4 had a deviation, and in my opinion it's not large. If you know about this stuff more than I do, let me know if this should be a reason to replace them. The biggest deviation is the second one that reads 220 microfarad and measured out 258. But for the rest, the deviation is just 1 microfarad, or even in the decimals, with a maximum of 0.2. So yeah, it checks out real nice, to be honest. So yeah, I'm not sure about the upper 4, but the owner of the ECU asked me to replace them, so that's what we're going to do next. And we'll start with cleaning the circuit board and cleaning up the through holes. Okay, it's the following day. The next thing I want to do is clean up the through holes. As I said, I scratched it a little bit over here. That's something that I wanted to prevent, but it happens, I guess. So here you have the through holes, and there's always a little bit of solder left in there. I want to get rid of it. I cannot get it out with the desoldering station. It's pretty hard. I want to try to use my solder wick, which is in here, and otherwise the last thing that I can do is take a tiny little drill and drill a new hole in there. But there's a risk involved in that, and that is that you damage the via that is in there. If you damage the via, there is no continuity between the upper trays and the trays on the other side of the board. That's what I want to prevent. So I will start to do this. I will try to do this by using soldering wick. So I've cleaned the tip of my soldering iron and I re-tinned it. There are good videos on that. The method that I'm going to do is I'm going to apply flux on those through holes that I want to clean up. Then add a little bit of fresh solder. That changes the melting point, I believe. And then I'm going to use solder wick, place it over there, heat it up with a soldering iron, and that should pull the flux out of those through holes. So let's give this method a test on those 4 holes. Okay, now I should be able to wick the old solder off. Well, could zoom in, but only, let me get a pointing device. Those bottom 2 are now clean. I'm gonna carry on, but I'm going to do that off camera. So over here I made a little bit of mess with the marker, but then we have these ones, through holes are clean, and this was the only one. Let me get a camera up close that I couldn't get entirely clean, but all the other through holes and the circuit boards are now clean. What I'm going to do about this one, I'm gonna get a tiny little drill and drill this hole out. I have a small kit of 1mm drills. They are about the same size as the leads on the capacitors. So I'm going to use this. You have to keep 2 things in mind. One, this will leave a residue on the other side. So the small chips that come off need to be thoroughly cleaned. If they get anywhere in between the traces or another component, they can short the circuit, and you can all have very weird effects of that. You can feel the drill pull itself through. Okay, well, let's get the new assortment in the list, and we can start soldering the new ones in. I'm gonna start off with this board here at our position 715 and 716. Let's get those 2, which are 35 volt and 17 microfarad. Capacitors always have a marking which marks the negative, the minus side, and those markings are also, I hope it shows on the camera right here. These are the positions over here, and the minus side is marked with this minus mark. I hope you can see it. So you have to be pretty stupid to put them in the wrong way. It doesn't work this way. Let me put it upside down. It's a bit contaminated, unfortunately. Put some fresh solder on there. So I cut off the lids and I'm gonna retin some of the spots that were a little bit open. I've cleaned the back of the circuit board. I used a very mild solvent, but the problem is that this varnish coating that is on here does dissolve even in the mildest solvent. I'll have to live with that. I also went over with this, well, it's a skewer, and I made a dull point on there so I can rub off loose solder that is on here like this. Anyway, this is clean. What I'm going to do next is use some compressed air to blow off the last dust specks and do the same on the other side, and then we can put the ECU back together. The last thing I'm going to do is to mark all the caps that I replaced with a dot as a reminder that someone has been in here. It's blatantly obvious when you look at the other side because you can see that someone has been working on this board, but just for good measure I'm gonna place a dot on all caps that have been replaced. So it's about time to put the lids on. I made sure they are clean. So now it's done. I will print out a label that says that it has been recapped, so someone else doesn't have to do this job twice. I'm gonna clean off the corners with the screws. I'm gonna mark them so we can see that it's not been reopened. Well, there you have it. It's all done. I make a little dyno printer label on here saying when the capacitors were replaced, and yeah, I always mark off the screws with a lacquer marker, but this is a hobby for me. I don't give any warranty to my work. The owner of this pays for the materials, which is in fact only a couple of euros, and sometimes they give a little bit extra, but that isn't much. I mean, if I can save an LS400 or in this case a Toyota Celsior, I'm happy to do so. Just leave these marks. They say, well, we haven't touched it before, and I can see that the screws were loose. But anyway, this is going back to its owner. So all in all, this job took me about 2.5 hours. I take my time, especially with cleaning and trying to work neatly. So now you know how that is done. I'll leave a link in the description which capacitors go where, so you can order them yourself, and this only goes for this specific model number of ECU. Anyway, I hope you learned something. Thanks for watching, and I hope to see you on the next one. Bye!